All right, so I'm going to share my screen. So when you first share your screen, rather when you first turn it on, you'll have this, when you first double click, you'll have this screen come up when you load your software. Can you see that screen?
Yep.
Okay, it'll say 0 plates, and make sure there's nothing in it. That's your first sort of measurement of the day, if you will. This is just an image to remind you that there's nothing in it, so that it's actually zeroing on 0, and it'll manually, rather automatically go down, and it will pass and read a 0 for the 4 optical sensors and record that as its 0 position.
What if there are plates in there?
You shouldn't have plates in there.
Oh,
You
that's
mean?
it came with them in it.
Oh, well, that's shipping. Yeah, that's different. So in that's the way it should be. So on your, when you first receive it,
Yeah.
you can toggle up. Just toggle up once or twice, and I'll show you how to do that.
Okay.
As soon as you get it up enough to pull that out, then you can zero it.
Okay.
I'll show you once this is done. I'll show you how to toggle. I think I remember how to do that. Then I'll show you the circulator system in the back as well.
All right.
All right, so if you go in here and you open plates. See, mine's already open. Yours will be, if you click that button, yours will be active, and you
Yeah.
can open it once or twice. It only moves, I think, 5 millimeters per click. So if you click
Okay.
that once or twice, it'll be enough just to get it out. And then go up to the one above it and click 0.
Okay.
All right, that'll let you open it and get it open. So before I go any further, that's essentially zeroing it. I'm going to just unshare the screen for a second and show you the back. So there is noting on the back of what is in and what is out. So there's so on the back there's
As far as your coolant
yeah,
input and output, yeah.
yeah. That's all fine. That goes to the back of this. That's all fine. There's 2 little plastic clips that hold those ends on. Any questions on that? Probably.
No, except for since I'm in an environment that stays at 74 degrees, our lab, I don't need any antifreeze or anything in there, just
You
straight water.
do. You do. The reason why, it's not for the water, it's for the antioxidant.
Okay.
There's metals in there, and if you don't, it'll might take 2 or 3 or 4 years, but it will gum up.
Okay.
So when you turn this on, you can
Yeah.
just set that to 10 degrees, and you can leave it at 10 degrees forever.
10 degrees Celsius?
Yep. Yep. And that'll stay there. You can leave it at that. Now, if you don't have that on and you go to use a device, there's a flow sensor on the inside of this device it won't let you continue the measurements. It'll let you work
Okay.
plates, but when you click start test, the plates won't heat or cool. They'll just stay they'll stay at the plate temperature, but at the liquid temperature. Or sorry, you won't have any liquid temperature. They won't heat or cool. All right.
What's the percentage of coolant?
It's in your manual. I
Water?
think it's 30/70, but you should check the manual just to make sure. It's
Okay.
noted in there.
And
And
you're
I
just filling, yeah, I think it said fill it up halfway.
yeah. And I think we even sent you the mixture, right?
Yes, you did.
Yeah, I would strongly use that. Advise to use that.
Just use the pink straight mixture is already mixed.
It has a label on it. If it's mixed, it would have a label. If it's concentrated, it would have a label. I think yours is concentrate. I think you have to mix it.
Okay.
I think this holds several liters.
All right.
So I'll find out. If your manual doesn't say that, just let me know, and I'll find out. So 10 degrees, just leave it on permanently. That's all you have to do. Make sure you have the exit from the circulator going into the in on the heat flow meter. And then you can start your device like we just did and zero the plates. Now you're ready to either test or calibrate. Now with this device, yours, you'll want to calibrate. Are you going to run different temperatures? Or are you just going to do room temperature essentially?
Room temperature.
Okay. So there's yours would be either 1450D or 1450E. This is the NIST fiber board that comes with it. Value that. And the reason why is that's about $500, that piece of material. So don't put any books on it. Don't lean on it. Don't spill your coffee on it. Value it. So
That's the same piece of material that has come with several machines over the past
exactly.
2 decades.
Yeah. And it only changes in the letter. And it's interesting you say that because we actually have a piece of it that's C. I have one piece that's the letter C. And I'd love to get a hold of B and A, but that would go back 30, maybe more years. And I don't think I'll ever find it. I got a C because we bought this old heat flow meter, or sorry, took a trade flow meter on a trade-in. And inside of it was a piece of C, and it was kind of, I don't know, neat that we got something so old. And I measured it, and it's still pretty good, believe it or not.
Oh yeah.
So the new batch is E. So if you have D or E, those are still valid.
Okay.
So it sounds like you've get that far. So if you've zeroed it, that's all you need to do for that. And then I'm going to share the screen again.
You zeroed it. Now we're going to calibrate it.
Now we can calibrate it, and it would be almost identical if you're going to test. I'll show you the difference. So here we can, this little microscope is your, this calculator is your calibrate, and the microscope icon is your test, but we're gonna calibrate. So there's 1450D. If in fact I had 1450E, I would select that one. And all it is pulling from the calculation that that you get on the certificate. If you've ever done that in Excel, we just done that for you so that when you put in the upper plate, let's say you're going to do 20 degrees average, let's say, I don't know, let's say, you're probably doing a 20 degree delta. That's what we typically do. And your mean is 20, so it's automatically calculated that and pulls it into the to be run schedule. All right. So if here you want it to do a specific thickness, but you wouldn't do that with your calibration anyway. You would only go to a specific thickness on. Well, I say that somebody might do a specific thickness on calibrate. It just depends on what you're doing. But typically on the calibration, you let it do its automatic clamping. So we'll leave that auto detect. And if I was going to do more temperatures, I could do up. Let's say I increase this by 10 degrees. You can see it automatically adjusts those following ones like that. And then it would automatically go through and do each one.
Okay.
So I'll cancel these because we don't need them right now. But now I would close plates. And you'll see it close plates. When's the name of the last one of these you had? What was the model or the maker? I'm sorry.
I don't even remember.
It was probably LaserComp. It was probably LaserComp. They made a lot of them back in the 2000s. Okay, so our plate is closed. Now we have to start the test. So what it's going to ask you, it's going to say, where do you want to save that result? So,
all right.
You know, we'll just put test. Well, I'm not going to let this finish, of course, because there's not enough time to do that. But this is what it switches to. It switches to the screen. I'd close the door. Now, again, my circulator's at 10 degrees. You're better off to let that get to 10 degrees before you do too much. And you let it go. So what you're looking at in that row is the details of your test, the reference material, the mean temperature, upper and lower, calibration status. That means it's running. And the R means it's red because it hasn't completed. And what's pretty neat about the status is as it gets close to completion, it'll change to a green color. And then once it's done, it'll say complete. And why we did that, we had with several users that wanted sort of a hint if everything was going well. Let's say you had a bad calibration and it only told you at the very end garbage number. So this is a little bit of an early peek that everything's going well if you see that change color. There you see the two plates going to their respective temperatures, and on the right side is the composite flux of the flux sensor that's in the plate in the bottom and the flux sensor that's in the plate in the top. And that will look funny until it stabilizes, like it'll just move with the transient temperature that's going on inside until those plates get to the stable, steady state temperatures, and that flux will start look pretty stable. All right. Typical time is 30 minutes, 35 minutes per sample.
Okay.
Unless now, if you stick a 4-inch piece in there, it'll take longer, of course. All right.
All right.
So I'll cancel this, and when you do cancel it, it does open the plates. Now, if you had a bunch of rows there, it would just proceed with them. That I canceled that, but you'd see the rows right after each other. Does that make sense?
Yeah.
They would have been right after each other. Now, here's what's really neat about, I think we have a pretty nice software. I don't know if you remember the old software that you used to use, but we have a pretty nice software. Once it's done the plate opening. So if you're into the test mode, oh, sorry, here's test mode. So here you can load your calibration. Let's say this is it. That would be the name of your sample. You could again close the plate to record. Rather, you could close the plate to a specific thickness. So let's say you're doing a batting insulation that's really soft, and you want to test it at 25 millimeters and not let it compress smaller. You could just put that value right in here. Oh, I didn't put that there.
The only thing that I'm testing is polyurethane foam.
So you'll
spray
never
foam.
do that. You'll never do that then.
No. So, and do you think that's the right temperature as far as the 30 upper and 10 lower?
Again, I would do, for what you're describing, I would do a 20-degree delta at whatever mean temperature you want to do.
Okay.
I like 20. And put the highest temperature on the top.
Okay.
So all that did when I clicked that button is it's going to record what the thickness of the sample was. So it's kind of a cheating way of, instead of using calipers. All it does is go down and it measures it and it puts that number there so you can know what it is if you want.
Okay.
You might not need that at all. Normally, so I'll just clear that. Normally you would just say, I want to do one measurement. Now you can let it do several recordings of time at those same temperatures to see if it gets the same value over several recordings of time. Does that make sense? So it's not going back to room temperature and coming back. It's staying at the same temperature, recording a result, and then looking uniformly steady state again, then again, however many times you put here. All right.
Okay.
Now, let's say you had several temperatures. You can cycle, which is really neat. So let's say you had several temperatures and you only do one of each, but you want it to go through over and over and over. You could hit cycles and it would do each one any number of times and then go back to the beginning and do it again. So that's kind of a neat feature.
Yeah.
It's probably more of a life monitoring thing, but then again, you never know. So typically you would just do that. That would be probably your normal would be this right here.
Yep.
So once you close the plates. This is assuming this is my sample, of course. And you would start test. So these look very similar to each other, just some slight differences. You hit test and it would start running. So the difference here is that instead of a status of calibration running, it's testing running. And it gives you a column for thermal conductivity and a column for resistance. The other details are the actual temperature that the plates reached. So there'd be, it might be a difference of 20. Let's say one plate was 30, it might be 29.95 versus the set was 30. So it records the real versus what was set to, and then it'd be done. So once you're done your result, those two red will turn green, then complete, and then you have all your data. So as many separate schedules points you'd have that all those rows would be present, ready for sort of proceeding on the testing.
Okay.
And I think now if I stop this again,
R, is that related? Is that actually R value?
yep. No, that's resistance.
Okay. What about the K factor?
K factor, you take your conductivity, and you probably would convert to BTUs and multiply it by the number of inches in your sample.
Okay.
Right. So if you do, that's assuming your sample's uniform, homogeneous.
Yes.
So if it's 3 inches versus 2 inches versus 1 inch, that's sort of your R factor. So let's say, I'm hoping there's some other data in here. So here's a test. Here's a completed cal from before, and that's eventually what your plates will look like, and your flux on the right would be your combined flux. These are your completed calibration, or you can do file open. Let's look for. I'm hoping one of these is an actual test. Maybe not. Nope, not that one. Let's see. Okay. Maybe we can find something in here. So this is a complete test on a sample. So we have 0.039 watts per meter Kelvin. You can see we did it at a mean temperature of 25. If you want to mess around with these, you can do that. Now, here's where I was trying to get to. You can generate a report, which will do this. That's one version of getting your data out. The other version is to export to Excel. So there's your data. There's your data. So if you had a bunch of other points and temperatures and rows, it would all be there.
Actually, it's not showing me that
Oh,
spreadsheet.
I think it's only showing that one application. Sorry, let me share the screen. Screen. Okay. Okay, so that's what it would look like if you click File, Export to Excel. It will look like that. Okay.
Yes.
Essentially, it's identical. It's just in Excel. And the other one that you missed was generate report. It makes an HTML version of the same data.
Okay.
The other things inside of settings you'll probably never use are you can mess around with. So after you run a calibration, if you have this check verify, it will run a calibration and then immediately run a test on itself. And it's a really neat way of verifying your calibration's okay. So it'll just save both automatically. You can open them up and make sure the value you get matches what it should be. And then speed and accuracy, I wouldn't mess with that. But if you essentially want to make it go faster, you can reduce the accuracy. Plate idle temperature. So let's say you have a bunch of samples and you want to test them all at 40 degrees. You could keep your plate at 40 at a mean of 40 degrees, so that when they're open, you can take the sample, put them back in, and the plates are automatically at the delta created for a mean, so that you save a little bit of time. You probably wouldn't save much time. Well, it's up to you. You could do it though. You just change these to whatever you want them to be, and you would save that time in between. You still have to wait for steady state conditions. Timeout would be if you have a bad test, how long do you want to let that go before the instrument just gives up? I wouldn't mess with any of these. Just leave them.
Okay.
Other than that, yeah. Any questions?
No.
Pretty
Not
basic.
yet.
Pretty basic.
Yeah, it's pretty straightforward.
Yeah.
I'm probably going to run this tomorrow morning. If I do have any other questions, I'll
Run a
definitely.
calibration. Give it time. Run a mean of 25 or 20, whatever you prefer, and let her go.
Perfect.
All right.
All right, my man.
Turn
I
your-
appreciate it.
No problem. I'll send this link to you if you have any questions, and we'll go from there.
Okay, perfect. Thanks for the time today.
No problem. Take care.
All right. See you.
Bye bye.